Picture a Land Cruiser crawling over a boulder field in the Australian outback. 3 tires are planted firmly on rock. One tire, the front left, is hanging in the air over a gap, spinning uselessly at thousands of revolutions per minute. Nothing happens. The truck just sits there, engine roaring, going absolutely nowhere. For decades, this exact scenario ended trips, stranded expeditions, and embarrassed off-road drivers who had paid a fortune for a vehicle that was supposed to go anywhere. The culprit wasn't the engine. It wasn't the tires. It was a mechanical weakness buried inside the axle, one that Toyota would eventually solve in a way that changed off-road engineering forever. And today this story explains exactly how they did it. Every vehicle with an open differential shares the same fundamental flaw. When power reaches the axle, it always follows the path of least resistance. On pavement, this rarely causes problems, because both tires usually have similar grip. But the moment one wheel loses contact with the ground, whether it's lifted off a rock, sitting on ice, or spinning in mud while the other wheel stays planted, the open differential sends nearly all of the engine's torque to that single, slipping wheel. The wheel with traction receives almost nothing. This is the single-wheel skidding problem, and for off-road vehicles it wasn't just inconvenient, it was often the difference between completing a trail and calling for a tow truck. Toyota engineers understood this reality better than almost anyone, because Land Cruisers were being driven through deserts, mountains and jungles on every continent, environments where a single spinning wheel could end an expedition hundreds of miles from help. The earliest fix, one that car makers had used since the 1950s, was the mechanical locking differential. Engaged manually by the driver through a lever or a switch, a locker physically forced both wheels on an axle to spin at exactly the same speed, guaranteeing that torque reached the wheel with grip. Toyota built locking differentials into serious off-road models for years and they worked. But they came with real compromises. Lockers had to be switched on and off manually, they were harsh in tight turns, they added weight and mechanical complexity, and in a moment of panic, a driver unfamiliar with the system might never engage it at all. Toyota wanted something smarter, a system that could solve the single-wheel skidding problem automatically, without the driver even noticing it was happening. The breakthrough came through a technology Toyota called active traction control, widely known by its badge name A-Track. Rather than relying purely on mechanical differentials, Toyota engineers borrowed a concept from anti-lock braking systems already sitting on their vehicles. Every wheel already had a speed sensor as part of the anti-lock brake system. Toyota's engineers realized that if a computer was already watching how fast each wheel was spinning many times per second, that same computer could detect the instant one wheel started spinning faster than the others, the telltale sign of lost traction. Once detected, instead of doing nothing, the system could apply the brake to that one spinning wheel individually. This was the elegant part of the solution. Braking the slipping wheel forced the open differential to behave as if that wheel had resistance again. Since torque always follows the path of least resistance, and the spinning wheel was now being held back by the brake caliper, the differential naturally redirected power toward the wheel that still had grip on the ground. In effect, Toyota had created a limited-slip differential using software and brake calipers instead of clutch packs or locking pins. No mechanical locker needed to be engaged. No lever needed to be pulled. The computer reacted in a fraction of a second, faster than most drivers could even register that a wheel had lost grip in the first place. Toyota introduced this system on the Land Cruiser Prado and later brought it to the full-size Land Cruiser and the Lexus GX, badging it prominently as part of their off-road technology package. Engineers tuned A-Track to work in conjunction with Toyota's terrain selection systems, allowing the computer to adjust braking aggressiveness depending on whether the driver had selected a setting for mud, sand, rock, or loose dirt. On rock-crawling terrain specifically, where a single wheel lifting off the ground is common, A-Track proved transformative. Vehicles that once needed a driver to manually lock a differential could now simply climb, with the electronics handling wheel slip continuously and invisibly. The proof of this technology showed up almost immediately in real-world testing. Off-road journalists testing the Land Cruiser Prado and later the redesigned Land Cruiser found that vehicles equipped with A-Track could climb obstacles that left comparable trucks with only an open differential completely stuck. In documented rock-crawling tests, a Land Cruiser with 3 wheels on the ground and one fully lifted continued climbing forward, the lifted wheel briefly spinning before the braking system caught it within a fraction of a second and redirected torque to the planted wheels. Toyota's Hilux and Tacoma pickup trucks, built on similar underpinnings, carried the same technology into markets across Africa, South America, and Southeast Asia, Regions where reliability on unpredictable terrain wasn't a luxury feature, it was a daily necessity for farmers, miners and rural communities who depended on these trucks the way earlier generations depended on horses. What made Toyota's approach particularly clever was how it scaled. A-Track didn't just work between the two wheels on a single axle. On four-wheel drive systems, it could apply braking to any wheel on the vehicle, front or rear, coordinating all four corners to fight wheel slips simultaneously. This meant a Toyota with A-Track could handle situations far more complex than a simple locking differential ever could, scenarios with diagonal wheels losing grip at the same time, a situation that would defeat even a mechanically locked axle. The system effectively gave Toyota 4 independent points of traction management using hardware that was already sitting on the vehicle for braking purposes. It was a masterclass in solving a mechanical problem through software rather than adding more mechanical parts. What made Toyota's approach particularly clever was how it scaled. A-Track didn't just work between the two wheels on a single axle. On four-wheel drive systems, it could apply braking to any wheel on the vehicle, front or rear, coordinating all four corners to fight wheel slips simultaneously. This meant a Toyota with A-Track could handle situations far more complex than a simple locking differential ever could, scenarios with diagonal wheels losing grip at the same time, a situation that would defeat even a mechanically locked axle. The system effectively gave Toyota 4 independent points of traction management using hardware that was already sitting on the vehicle for braking purposes. It was a masterclass in solving a mechanical problem through software rather than adding more mechanical parts. The legacy of this technology is visible today in nearly every serious off-road vehicle on the market. What Toyota engineered as a solution specifically for Land Cruisers navigating rocky trails became the foundation for traction management systems across the entire industry. Modern trucks now combine brake-based traction control, electronic locking differentials, and terrain selection software into a single coordinated system, but the core insight remains exactly what Toyota discovered decades ago, that a wheel spinning freely in the air can be tamed not by adding more mechanical hardware, but by teaching the brakes to think. The single-wheel skidding problem that once stranded off-road drivers across the world didn't disappear because engines got more powerful or tires got stickier. It disappeared because Toyota looked at a braking system already sitting on the vehicle and asked a simple question: what if the solution to lost traction wasn't more power, but smarter braking? That question turned a frustrating mechanical limitation into one of the most quietly effective technologies in modern four-wheel drive engineering, one that most drivers benefit from every single time they climb a slippery hill without ever knowing it's working. So that's the story of how Toyota solved a problem that had plagued off-road vehicles for generations, not with brute force, but with a clever reuse of technology that was already there. If you drive a Toyota with four-wheel drive, there's a very good chance A-Track has saved you from getting stuck without you ever noticing. Let us know in the comments if you felt this system kick in on the trail, and what vehicle you were driving when it happened.